calling on Adam. Adam? Okay, amazing. Thank you. We'll be calling on Ratan from Succinct. Okay, amazing. Then we'll be calling on Dr. Martins, Derka. Awesome, awesome. Then the moderator for this panelist session will be no other person but Evin. Please a round of applause for Evin. Thank you. Let's go.
GM, everyone, thank you so much for joining us in the zkEVM today to talk about our favorite things. Big appreciation to our hosts here today at the ZK Hub. Really appreciate you guys holding space for these important discussions. So to get us kicked off, I'm going to invite our esteemed panelists to say a quick hello, remind us of the role that you have, and tell us, what was the last ZK application or service that you used?
All right, so pleasure to be here. My name is Martin. I am a technical co-founder at Zircuit. We built a zero-knowledge rollup, and this is the last ZK application that I have used. It's Zircuit.
Hey, I'm Ratan. I'm a founding engineer at Succinct. A lot of fun to be here, and I have to go with a similar answer. The last thing I use is SP1. Yeah.
Hello, I'm Adam Domurad, a staff engineer at Aztec, and the last ZK application that wasn't just our rollup would have to be the in-progress ZK email verification software that's being built on Aztec.
Hello, I'm Jordi Baylina. I've been developing the zkEVM and been in Polygon for last years, doing a lot of ZK stuff. And the last ZK application that probably is going to be some rollup, but yeah, the one that I'm more proud of is Tornado Cache. I think that we cannot forget that, and that's still a good application to use, and we need privacy, so yeah, I want to mention that.
I'm Porter from Matter Labs. One of the teams building zkSync, and yeah, I think besides zkSync, the last ZK app I used was zkEmail.
Awesome. And GM, guys, my name is Evin McMullen. I'm the co-founder and chief strategy officer at Privado ID, your host today, and I also used zkEmail most recently. So thank you guys so much for reminding us, and you definitely want to encourage everyone in the audience to try out those platforms. So for a little context setting today, obviously we are all acutely aware that L2s have become a norm in scaling blockchains like Ethereum and even our friends over in the Bitcoin ecosystem. While optimistic rollups have, of course, played a major role in this evolution, zkRollups are increasingly becoming sort of seen as the future due to their inherent advantages in terms of security, finality, and efficiency. So today we're going to discuss what the role of that evolving space looks like with respect to optimistic rollups, to ZK technology, and how they may or may not play well together in the future. So to start off, let's talk about the disparity between these two technologies and get a little base definition here. I also want to encourage our panelists for some healthy disagreement. There's nothing worse than 6 people hanging on a stage and all telling each other how cool they are. So this is a comfortable and welcoming space for a little bit of friction, and I invite us to try to find one thing to disagree with a little bit from the person who spoke before us. So to get us kicked off, ZK rollups are often described as being inherently more secure and efficient than optimistic rollups. Can we start the discussion by identifying some key advantages that ZK rollups have over optimistic rollups, so we all kind of start with that shared understanding? Want to kick us off?
Sure, sounds good. So the primary difference between ZK rollups and optimistic rollups is that in ZK rollups, in theory, nobody should have the chance to cheat, right? You have your zkEVM, you have some circuits that produce zero-knowledge proofs that make sure that the EVM transitions were executed properly, and as soon as the proof is ready, you know that nobody cheated, right? This has very strong impact when people are withdrawing their assets. What we are doing in zero-knowledge rollups, we let them burn or lock their ether or whatever asset we are talking about. Then as soon as the rollup produces a proof that this has really happened, that proof can be provided on the L1, and then as soon as it is verified, the person can finish exit with their assets, right? This is not the story of the optimistic rollups. In optimistic rollups, everything happens optimistically, then you have to wait for the challenge period, and when the challenge period elapses, regardless of whether somebody cheated or not, you are allowed to finish your exit, right? Because nobody challenged you, nobody actually proved that there was some cheating that happened. So So this is what sort of revolves around security and why people say that zkRollups are more secure. I disagree in here that zkRollups are always inherently more efficient. This efficiency, it actually does come in this realm of exits, but it's sort of difficult to find it all throughout the stack of the rollup.
Yeah, I think I would agree that zkRollups are not inherently more efficient. In fact, you're paying the proving overhead, so they're inherently always going to be less efficient than running an optimistic rollup. But I think it's really in the context of having many different rollups where I think zk shines, right? Like people have talked about having great interoperability solutions between optimistic rollups, and often a lot of the designs are not that elegant. You end up having to run, if you have n chains that you want to have interop between, you have to run n different nodes, which is just not scalable in the long run. With zk, clearly the design there is better. I think that to me is one of the biggest places where it's not just the self-verifiability, but interop just becomes so much easier for a team to build. And I'm sure, at zkSync and at Polygon, you guys have seen this a lot too. And it's something that we're really excited about as well. So yeah, I think fast finality, interop.
All right, so I'm going to try to add something different here, which is, there's a difference between validity rollups that use zk technology and what I would consider zk rollup, like what Aztec's doing. And the main thing there to point out is that optimistic rollups do not really provide a way to do privacy. You'd have to use another privacy technology, while zk allows people to do client-side proving and add privacy, which I think is a feature greatly lacking from most blockchains.
I'm going to be here a little bit disappointed somehow, because zk is a great technology. I would say if you want to do the things in the right way. If you are interested in decentralization, if you are interested in doing things that that nobody controls, that are human, common goods that belong to the human, and then you need the zk. I think that that's the way to go. But if you don't care, if you just want to build a kind of a bank that we are not, I would say that most of the rollups today, they are not even zkRollups or optimistic rollups. They are multi-sig rollups at the best. So, and it works. People like it, and people care about other things. It's just a kind of, we are seeing the space, mainly it's gambling, DeFi gambling, just people just playing poker between whales playing there. You can run that in a centralized server. Maybe centralized server is too risky from legal issues, so let's just build some multi-sig or something, and that works, and that's great. But, that's not what I really want to build. I want to build things that, that are decentralized. Bitcoin, it's like this idea that's behind. And for that, you need the tech. You mentioned before, if you want to communicate trustless, not with a bridge that somebody has some keys again, but if you want to communicate between that, you are gonna need some sort of proofs, and of course, zk proof gives you this immediate validation, and you don't need to wait for this gaming there, and this is much superior. But again, if users don't care about decentralization, privacy, I fully agree. That's the next step, and I think that this is you are in advance here in the space. If we don't care about that, then really we don't really need zk, definitively.
Yeah, I think the story so far has been zk is better because of the faster finality, because you can withdraw after the proof is complete in a couple hours instead of waiting a full week. But turns out a lot of users don't care that much about that. It's not a big differentiator. I think, it's these trust assumptions, and today when there's only maybe 5 or 10 optimistic rollups that have a lot of volume, I'm pretty convinced there's going to be enough people there to generate a fraud proof if I need them. But if we imagine a future where there's closer to 1,000 rollups, I'm much less convinced that every single one of them is going to have enough people for a fraud proof, and I'd way rather depend on zk for the trust assumption.
Yeah, one of the things of the optimistic of the optimistic world, is that it implies, so in order to be optimistic, that means that you need to follow the chain. I mean, you need to check the chain, and that means that you need to run the chain. And this is, it's very much the problem why the things do not scale in consensus, because there is a lot of people that needs to follow the chain. So an optimistic is very much the same. So if you want security, you need to have a lot of people that needs to be connected and follow the chain. And I mean, if you compare that on, you don't have to follow a chain. Maybe somebody just built a ZK and gives you a proof that this chain is correct. Verification is much, much, much easier. So this is, I mean, this concept is why one of the reasons why ZK is so superior to optimistic.
So it sounds like we have a new phrase here. I like the multi-sig rollup as a descriptor. But if we were to think about, what can the bull case look like for an optimistic rollup, understanding that it's going to require some amount of observation effort, understanding that there are certain trade-offs, especially with respect to user experience. But now that we've heard all of the benefits of ZK, let's try to make the bull case for what use cases might benefit from optimistic approaches, understanding that, of course, as Jordi noted, some of those are likely to embrace centralization and discard consent. But what do those look like? Just to challenge our initial set of views.
So there is one thing that I consider a clear advantage of optimistic rollups, and it's the ease of understanding. If you imagine a zk rollup and proof system that is broken, it's, for example, not sound, right? So you can have actually two proofs or like a falsified proof that proves some transition, some kind of a fact. If you imagine that you go to your friend who is absolutely not technical and try to explain to them what went wrong and why their $10 million just like disappeared because there was not sound proof, they will not understand what the sound proof is. They will ask you whether snark is a swear word. You will stand zero chance of actually making them understand. When you take it optimistically, you will say, okay, well, the rollup is supposed to go from here to here, and it did not. Here is a proof. You cheated right here, right? This is actually pretty transparent. So in some way, the optimistic rollups, they're actually conceptually much simpler than the ZK rollups, and that can be a benefit in many cases.
I'm gonna disagree with you here. I think it's, at least for me personally, I think it's much harder to reason about the complexity at the rollup design level when you have to design a fault-proof game. I spent a lot of time looking at Optimism's fault-proof stack. I don't know if you've ever taken a look at it, but not only is the dispute game complex, but the contracts themselves are quite complex too. In contrast, for a ZK rollup, let's imagine that you can take, let's say, a zkEVM as a foundational layer. We abstract away, we're there exists some censorship-resistant layer that is being run all around the world. This allows us to build DeFi, right? I think similarly, people are no longer going to think as much about, oh, this ZK system has all these nuances and complexities. They'll take a zkEVM for granted. It'll become foundational. And then things like, securing your rollup become much easier to reason about. I'm hey, we have a cryptographic method for showing that our rollup is secure. It works. It can prove any arbitrary program. And it's been audited by the community over the course of many years. The same way that, blockchain node software, if you tried to reason about it every single time you built an application, you would go crazy. So I think here, I find that ZK is much easier to reason about, but we're in an interesting transitory period where, we used to have to worry about the nuances about how each proof system is designed, but when there's consolidation, I think we have to worry less. So, but to your original point, why are optimistic rollups better? I think my kind of take on this is that until you have real-time proving of ZK rollups, there's going to be some delay before you have finality with ZK, and so you need some optimistic either bonding system to get that immediate interop liquidity. And I think that's where optimistic will dominate, which is in contrast today, where the windows are multiple days. Now I think you'll see liquidity-based systems. I don't know if I'd classify that as optimistic, but that are not ZK that allow you to do interop faster. So yeah.
All right, so yeah, I definitely agree with most of the points already said. I would take the stance definitely that overall for mere mortals, the inner workings of an optimistic rollup are, they don't require the domain knowledge of zk, which is pretty much a particular topic in itself. And definitely, I do agree for sure that the kind of bugs that come out of zk can be very hard to explain to a layperson, with the flip side being that verification is a lot easier in the zk space. You don't have to follow the chain to be convinced it's correct. And I guess the point I'll make is that the basic economic game behind optimistic rollups is always a consideration. So I think there's a tool set for rollups. And if you consider the optimistic approach to zk, you get stuff like naysayer proofs, where if you want to most of the time not actually verify proofs, only if somebody challenges it, then you get a little bit of optimism in zk. So I think, as always, it's a set of tools.
To mention various things here. The first is that zk, I agree that if you are trying to get inside the zk box, it may be complex, but it's also a lot of difficulty if you are trying to check a signature, how it works, and it's a black box. So if you accept that zk is a black box, a complex black box, but it's a black box, I think that zkRollups, they are much easier, easily conceptually than optimistic rollups. Optimistic rollups, I mean, they are based in the assumption that the blockchain is a real-time thing, and it's not a real time. And the way to convert something that's not real time with real time is just by delaying things. But it's not. So there is a lot of complexity. So I agree that there is a lot of complexity in the optimistic rollups. And zk is, of course, then we need to go inside the zk. I mean, the zk box. Okay, and I agree. So zk box are very complex compared to a signature. I mean, the zk is something that's some orders of magnitude more complex. What's in there, at least in number of pieces that are in there. But here the good news is that the maturity that's getting this technology is improving a lot. I mean, still a lot of things to do. There are interesting things that are happening. I think that right now the VMs, people see it, they are. Look, when I remember, for example, at the beginning when we created the zkEVM, we were talking with Linea people or with even maybe I think with zkSync people too. I mean, we were talking and trying to follow this idea of Vitalik of having two provers that they prove the same thing, but if one was implemented wrong, then at least you have the other that at least can shut down the network. And by the time it was impossible, because when we were type 2s, the things were very different, and we are changing things, so and it was very difficult at the time. But now with the VMs, at the end you are just proving a Rust program there. The Rust program can be the same, but then the black box, the zk, can be very different and can be very differently implemented. So having this idea of having two proofs or two types of proof or three types of proof, this becomes now possible, at least much more than was 2-3 years ago, and this can improve security also on that side. And the other topic that I wanted to mention is also the improvement that we are doing in real time. So I think that right now, so thinking in doing a block proof in seconds is a reality today, and it's getting lower. So, and this also will simplify a lot of the zk, because I hope that at some point we stop introducing this optimistic thing because the proofs are so fast that it's just pure zk rollups.
Just quickly on the backup for the zk proof, zkSync does have TE proofs also, and so hopefully, like, even if there's a bug somewhere deep in the cryptography, like the TE proof will catch it. But I think generally the point that hasn't been discussed yet is cost for user transactions. Like the overhead of running zk proofs is still relatively high today compared to just the raw computation. and this is affected by most of the ZK rollups being like slightly more expensive than the optimistic rollups. I think ZK technology keeps getting like better and better, and I have a lot of faith that we actually will get it to be like as cheap or nearly as cheap as optimistic rollups. But for now, the like cost does affect end users, and that's a problem.
I have a quick reaction. Can you please say what the T in TEE acronym stands for?
Trusted execution environment.
I think you brought up an interesting point earlier, which was that people don't really care about fast finality. I think one thing that's interesting is, like, let's imagine a world over the next 2 years where, proving costs have dropped 10x year over year, like maybe even more. And it's interesting in that I do actually think that fast finality is quite important. I know a couple folks who are like working on a protocol that's like on a rollup, and they've had multiple people that want to use their application tell them, hey, we can't use this because we don't want to bridge our money to a rollup where we have to keep it there for 7 days. And if they're moving enough size, they can't use a cross or some bridge provider to get their money off of the rollup. And so I think in this transitory period, we're going to see that the proving costs are inherently going to be more than optimistic rollups. But if you can drive enough demand and the applications themselves are able to exist on the ZK rollup because they fundamentally can't on the optimistic rollup because people aren't willing to put their money into an optimistic rollup, then I think that cost is no longer as much of a concern. So I do think there's it's not just like, oh, cost is worse. There are actually better user experiences that come about from having ZK. And I'm sure you guys have seen this too. Yeah, I find that to be really interesting, at least. It's just like there's always some tension going on here. And I think the moral arguments to me for ZK, I personally resonate with, but I think it's very hard to make that compelling to an application. They care about getting users. Something that's very concrete is no one is ever going to complain about how they can't take the money off the rollup as a reason why they can't use your application.
So I think we raised a few very interesting points about the improvement of user experience, right? Having a conversation about optimistic rollups versus ZK would have looked a lot different a couple years ago as we were waiting for 30 minutes for these proofs to generate on our desktops. So, of course, it seems like our panelists will all be very adept at explaining both types of rollups to their families over holiday dinners. But before we think about what these different technologies are going to look like together in the coming years, would love to drill down a little bit more on that UX question. We've talked about waiting periods. We've talked about finality. Are there other aspects of UX between these two approaches that you think are meaningful, whether for end users or even for the DevX of applications building on top, such as the folks you guys mentioned earlier who need to make money to have businesses?
So this is a loaded question. Here's the deal. When you're looking at rollups, the end user experience and the UX that relates to this, it's like such a multifaceted kind of view that it doesn't boil down to only ZK versus optimistic, right? We have EVM equivalent or compatible zero-knowledge rollups, and we have completely different ones, right? They introduce new languages that are more suitable for proving in the ZK setting and so on. This obviously does impact the end user experience. You will not have the same tools, you will have different programming languages if you're a developer, you will probably have different wallets, and so on. And there are projects, some of them are sitting right here, who showed us that this is actually possible, right? And maybe there is a good chunk of people who actually doesn't mind, but there is a difference, and there will be a difference. Other than that, I think that the experience when it comes to rollups for the users, aside of those exits and all that, it actually might look very, very similar. So it's more about, what are you willing to interact with? Are you okay with the optimistic approach, or are you not okay with the optimistic approach and require ZK? The last thing that I will bring up is, it also depends. What do you really consider to be a ZK rollup, right? We had a comment here from Aztec, which related to some client-side proof generation, right? Well, in that case, you probably will have to make sure that you have sufficiently strong hardware, which if us engineers, we do our work properly, it will actually be a non-issue. So in the end, that user experience might be, rather similar.
I'm going to be a little bit controversial here again.
Perfect. Let's hear it, Professor.
Look, probably UX is the worst enemy of decentralization. And let me explain. I mean, if you are trying to build an application and you prioritize UX, I tell you, you are going to sacrifice some sort of decentralization on there for sure. Because I mean, you want immediate things to happen. You want fast reaction. I mean, you want giving to the user, but there are things that are not possible yet. I mean, a consensus takes some time, and this goes against UX, whatever you do. So you need to deal with that. So when we talk about UX, I mean, of course, we need to do the things usable. I mean, if you want this technology to go to mainstream, we need UX, and I fully agree on this statement. But we cannot forget what we are building. At the moment that we are prioritizing, and when I'm saying prioritizing is that we are sacrificing the values of the community for the UX, I think that we are going against the community. But again, this is from the business perspective, probably that's the right way to go. I mean, if you are building a product and you want to sell a product, I tell you, you have to go for UX, for sure. But what we're building here?
Yeah, I'll push back some. I think maybe within the rollups that the UX is like not as obvious, but I think if you bring ZK to the application layer, like there's things that are infinitely better UX that only happen with ZK. So for example, zkEVM, Clave wallet on zkSync is using it for, you can prove that you've sent a reset email to recover your account. So if you ever like lose your private keys, you just like zk prove one email, just like a Web 2, like forgot your password reset, and like you can get your account back. There's no way to do like optimistic like email reset. Like it has to be zkEVM. And so I think there's going to be a lot of cool things closer to like the user and application layer, where ZK is just like strictly better user experience.
I think that's also a great note to call out. There are some types of data, such as identity, for which an optimistic take is not sufficient. And so, very important for us to contemplate those use cases. Quick show of hands from our audience today. Have you guys ever opened up an app or a service and looked at the type of rollup it was built on and said, nah, don't dig this rollup, not gonna work for me? Is that a decision that you guys weigh in how you choose apps or services at all? Interesting. So it sounds like the thorough complexity and desire for our users to understand and make distinctions between them may not be as present. Sounds like also that the sacrifices around decentralization that, for example, enterprise chains built on optimistic rollup stacks are making right now are catering to that sort of apathy. As we look at the proliferation of so-called enterprise chains, right, the bases of the world, the uni-chains of the world, why are we not seeing enterprise zkVMs? Or do we think that we will start to see more of them in the future as these improvements are readily available?
Soon.
Yeah. I mean, I think that in the case of Polygon, the aggregation layer, this is very much about that. This is, I mean, the ZK tech is very important for this, transferring these things. When we're talking before, I mean, some years ago, building an enterprise chain means building a L1 chain, which is, I mean, and you just join the word L1 and business, and then you will see that this is impossible thing. I mean, it's a difficult topic. So at this point, so business, they don't need to build an L1. They can build an L2, and it can be a private L2, and this is going to be a normal thing that you will build in any of these aggregation layers that we are building.
Yeah, I think with zkVMs, it's just a matter of maturity, because definitely when it comes to the Web 2 privacy model, it was very practical. And the idea that you kind of have some obscurity into the going-ons with a zkVM can definitely turn off enterprises. But I do think, to kind of harp on privacy, there is when it comes to enterprises using the blockchain, there definitely is a strong emphasis as we get mainstream adoption that businesses want privacy, and that is something that ZK enables.
So yeah, I think that's a really great call, is that businesses, operate in competitive environments. And the idea of disclosing the entirety of their order book or their client list to their competitors in a permissionless way is suboptimal to their bottom line. So if we think about that premise and how it might impact the sort of enterprise chain landscape, and Jordi, that's a great call out also. In 2017, we talked about enterprise chains as private permissioned L1s. And today they are inheriting security of other protocols and utilizing tools like zero-knowledge proofs. So as we contemplate the idea of change management, what would it look like for an optimistic chain to upgrade or to make this migration? And maybe Jordi, I'll pick on you because I know the Polygon POS has contemplated the future journey toward zkEVM. So what does it mean to examine change management for a whole chain in this way?
It's a nightmare, I would say. It's the problem of migrating chains that they have a lot of volume, and we see that in Polygon, but we see it also in Ethereum every time that we do an upgrade, or probably in the other stacks. So when a stack has a lot of TVL or a lot of things that happens there, you need to be very careful when you upgrade and where you are doing things in there. So that's why that's why the things sometimes go slower. Development, sometimes it's better to spin up a new chain that has less TVL and things, but at least you can play, and if you break it, it's less painful than if you are doing that. So that's one of the things, important things to consider. The other thing is that when you are upgrading things, it's important to understand this centralization. So this involves some sort of centralization. Upgrading a rollup, we go into a multi-sig again, or maybe you can put some time lock, which is okay. It's better than nothing, but it's some sort of centralization that goes there. If you think in the end game, in the end world, rollups should not be upgradable. They are just there. It's just. They don't belong to anybody. They just work, and people is using it. They are stable. For me, this is the end game. So all these, I would say, all this bootstrap, for me, this is part of bootstrapping something. One point that I want to, maybe I debate, because this is something that very worries me about, is that a protocol that starts centralized. When I mean centralized, I mean this multi-sig, upgradable, time lock, whatever. How hard is going to be to kill the multi-sig, or how it's going to be to so it's so I'm thinking like two scenarios. I would say if you just let the scenario go, I think that, so if you let the organizations that are building this to let it go, this will never happen. Because they have to destroy themselves somehow. So for me, the only hope is that there are some external reasons that force us to do that. Maybe there is some attack from some governments or for something that you cannot think, and then the only solution is, okay, let's decentralize, keep there, and then it's working. I hope when this happens, rollups are mature enough so that they can survive. But yeah, this is maybe it's a little early in the history to talk about that. Rollups are evolving, and zk technology is evolving a lot, and maybe we are very early stage, but at some point we will have to talk about that.
Yeah, I just want to agree heavily on, for me, the bigger change, and kind of the more you entrench centralization, the harder it is to move to a decentralized model. That's one reason Aztec is starting off with a decentralized model. I think that, as hard as it might be to move an optimistic rollup to a zk rollup, and kind of in my opinion, once you start doing regular validity, and especially as zk advances, I think they just basically become zk rollups. But I think the bigger challenge in the rollup space, and in some ways rollups are kind of, they lend towards centralization because that's the easiest way to just piggyback off Ethereum. So I think that's a much more important transition and the harder one.
I think that's a great call out, though. Remember, upgrades are centralized. Hardware is centralized. Energy is centralized. Access to the internet is centralized. There are a lot of different aspects of this we need to be aware of. Go ahead.
Disagreement about upgrades being always centralized. So I also disagree with Jordi that rollups, might not be upgradable, that they just exist and whatever, right? even if you have the most decentralized rollup out there, there is always a smart contract that the community or whoever is running the rollup agrees that this is that smart contract that we are rolling up the state, or maybe the proofs, and this is the DA that we are using. If there is a necessity for an upgrade, even in the most decentralized world, if everybody agrees that we are no longer going to be using this smart contract, we are going to be using this one, and it's also going to have a verifier with it, then you have upgraded your rollup, and you don't need any centralization. It's about the consensus.
Yeah, probably was not thinking on rollups as, a private chain is a rollup too, and it can be super centralized, but I was thinking more, and each rollup is, should be sovereign by themselves, and I fully agree on that, but I was thinking in rollups, let's say public rollups that don't belong to anybody by definition. It's like the thing. I was thinking on this kind of rollups, but yeah. I understand your point.
Do you have something else you wanted to add?
Yeah, I think we found that, or I think before moving to a zk stack for an optimistic rollup was infeasible, right? Like, especially when you make trade-offs on what type of EVM you're going for. That state migration is like tremendously difficult in a pain, right? Like, I'm sure that Polygon and zkSync know this acutely. Asking someone to change their Merkle tree that they store all their state in is horrific. And one thing we've really prioritized is, I think this upgrade path is getting much easier, especially as, optimistic rollups. I think both Optimism and Arbitrum are aware of this, and they've designed their systems in such a way where it is flexible. For us, like, we recently launched this project called OP Succinct, which takes like any OP stack chain and converts it into a fully validity proven OP stack chain. And that upgrade path is like dead simple. You literally upgrade one contract that is storing the state roots. You modify one function. Basically, whenever you're posting the state root, you now post the state root and a proof. It verifies the proof, and you update the state root. So from the contract level, I think upgrading is quite easy. And these like external services you spin up to like generate proofs are also simple too. I think it's just that when you're thinking about having to upgrade with a different type of EVM, then it's bad. But now that I think type 1 proving is more computationally feasible, the costs are becoming lower, and as long as we keep going down that path, it's going to be quite easy to upgrade. And I don't think this like state migration problem will be as big of a thing anymore. That's at least my personal belief, is that, yeah, this is the direction everything's headed. I think upgrading will be easy. It's just going to be a question of, does that rollup want to make the trade-off today of, we want fast finality today because applications demand it today, or they're willing to pay the proving costs, which are going to go to near zero long term, right? So this is, what gets interesting.
All right, so as we move toward that long term, let's think the next 3 to 5 years out. Would love to check in on what that looks like. Are we happily coexisting with this diversity of stacks? Have we achieved that migration? Were there incentives involved to make some of those migrations happen? How do you guys think this is going to play out?
So my opinion is that we will coexist. The space is big. There is a lot of capital everywhere, and in the end, we sort of somehow agreed, maybe even involving the audience, that the users, in the end, some of them do not care about transacting on zk versus optimistic rollup, right? And as long as we have enough of them, then yes, we will coexist, and it will make sense. So I think that we will coexist. At the same time, I think that the evolution of zk rollups and zk technologies in general will actually be speeding up. The point brought my friend here from Succinct is actually really, really valid. So up until this point, when we were developing zero-knowledge rollups and zero-knowledge technologies, we always had some application logic that we had to encode in some circuits, right? Be it Zircon, be it Halo 2, be it something. If that logic changes, you suddenly need to make a change in your circuits, which sort of like brings a little bit more complexity to the table, more work, more development needed. When we come to these general VMs, that's no longer needed, right? Because in the end, you make your change in the logic, in the Rust program that you want it to have, then you compile it, and it keeps proving. It gives you a new verifier, the crypto system, right? And it keeps proving. You don't have to do any extra work. So I actually think that the rate of innovation will be increasing. The number of zk rollups that we are going to see is also going to be increasing, but we will always coexist.
All right, inviting 1 or 2 more hot takes. How is this going to play out, guys?
I have a question for Porter and Jordi. Do you think this mechanism of the ag layer or zkSync paying chains will continue in 5 years? Like, Optimism has this approach today. It's mutually beneficial in some ways, but clearly there's a lot of grant money being thrown around to get chains to move on to a specific stack. What's the equilibrium of that, right? Like, everyone wants to bring a rollup onto their layer. Like, what does that look like in 5 years? Because I imagine it's something that we think about a lot, where it's it seems kind of unsustainable in some ways. How do you think it looks in 5 years? Like, are people going to be continuing to have these agreements from the foundation with rollups? Will that go away? Yeah.
I would say it's a matter of, it will depend very much on the friction for the composability between rollups. The way to scale, and this is, I've been thinking a lot on that. The way to scale is with many rollups. I mean, internet is a set of chains, a set of nets, and they are sovereign, each net is sovereign by itself. And blockchain is going to be, it needs to be very much like that. I mean, everybody should be able to build chains, and their chains are different in a sense, with different token, with different security things, with different block times, with different rules, gradability rules, with different, even the state transitions. So there is a space where each chain needs to be sovereign and needs to be a freedom on creating new chains on that. And everything matters, so the only thing that matters is how these chains communicate one each other. And the important part is the friction that there is in between this communication. Here, zk plays a huge role. I mean, having fast proofs is fundamental for achieving these fast and at the same time scalable. I mean, two chains can communicate fast, let's say relatively fast, if one chain follows the other. I mean, you need a commitment from the other chain and you need to follow the other chain. And this scale, I mean, this, if you have two chains, that's fine. But if you have thousands of chains and they are creating and destroying every time, you cannot spin a new server for each chain that's created. I mean, this model doesn't scale. Okay? So you need that each chain generate proofs, and this proof needs to be fast enough so that the funds of one chain, you can use it in the other chain. At the moment that you have a low friction, then having sovereignty, I mean, having these chains, that each chain is it's sovereign by itself, it's different. It's chain can be, I mean, a scam chain that's running there. It can be a very powerful, a government chain, a private chain. I mean, it can be a very different kind of chains, and they have this common thing that communicate one each other. In the ag layer in Polygon, we are building this. You can see that if you want in the Ethereum ecosystem, or if you want it at the blockchain ecosystem. I mean, how networks communicate one each other. And it's just a matter of friction. Probably, if you want to communicate, I mean, if you want to do a smart contract that calls another smart contract inside the same chain, the friction is, let's call it 0, okay? If you are calling a smart contract that's in maybe in the ag layer chain and the other chain, the friction probably is going to be much, so it's going to be very low. I mean, we're trying to minimize that, but we already need some connection there. If maybe one layer in the ag chain wants to call a network in the zkSync, it's going to be possible. Maybe we'll have to go through Ethereum, and maybe the friction is going to be a little bit higher. If you want to communicate maybe with some chain in Solana, you should be able to do it, but it probably is going to be even higher, this friction. But everything is about reducing this friction between chains. And again, the only tech, I mean, the tech that we need for that is the zk tech.
Awesome. Porter, take us home here. I'm about to get pulled off the stage. We're just about hitting time.
Definitely. Yeah, the people I disagree with are most of crypto Twitter, who thinks that like all of the L2s won't be interoperable eventually. Like the same reason like you don't want to be on the internet and not be using TCP/IP. You don't want to be like on a separate L1. Like if you just isolate yourself too much in no man's land, then like no one's gonna want to interact. Like your rollup's not gonna be connected to everyone else. For now, I think it's good that we have like Polygon ag layer and like zkSync and other teams like trying different interoperability approaches. I think it's good to experiment, but to me, it's super obvious that like the 5-year vision is we're all going to have like interoperability together, and that's definitely going to happen.
Porter, thank you so much. This is a great reminder. Everybody, you cannot have a blockchain by yourself in a corner. That is a database. So whether it is optimistic, whether it is a zk rollup, we all look forward to supporting you in your adventures on chain. Thanks again to our host today, and I think that is all for our panel.